Okay guys, so we're going to go ahead and continue with part 2 of adding and subtracting radical expressions. I do not have a do now for you today just because I want to go straight into these examples. Make sure I spend most time explaining these examples and not other stuff. So we're going to go ahead and we want to find what is the sum of the two rational expressions in simplest form. Okay, so they want us to simplify that. And now the other thing that they want us to do is they want us to state any restrictions on the variables. Okay, this right here, the second part of this is going to help us with the lesson for tomorrow with understanding what it is that we need to find. Okay, so we want to go ahead and we want to add these two. So it's going to be very similar to the other one. I need to make sure that I have the same denominator. Okay, and so that means that I have to go ahead and factor this stuff out. Now, the only thing that I have to factor out is this denominator right here, because this x is already simplified, this one is already simplified, and this is already simplified. So I'm going to go ahead and factor that denominator, meaning that you guys should do box method to factor that out, or tic-tac-toe. Now I'm just going to go ahead and try to do this in my head. So I'm going to go ahead and get x divided by x minus 1 plus 2x minus 1 divided by, well, I know that I'm going to get two factors. I need to find numbers to multiply to 2, which is literally just going to be 2 and 1. Now, I do see that this right here is a negative 3, so that means that that'll be a negative and a negative. Negative 2 minus 1 adds to negative 3, so all I'm going to do is just put an x right there. And that right there are my factors. Now, we have to go ahead and make sure that they have the same denominator, right? So we have to find the least common denominator. I'm going to be using the same steps from yesterday, so if you want to follow back on those as well. So I look at this here and I see that I have this x minus 1 and this x minus 1. So those two are the same. What is the only thing missing in the denominator? It is going to be this x minus 2. Now it is only missing from the first fraction, so that means that it is going to be the only thing that's going to have to be changed is the first fraction, and it's going to have to get multiplied by x minus 2. And what I do to the bottom, I do to the top. So now if I do that, this and this will be the same as these two fractions over there. So now I can go ahead and add my denominators. So I'm going to go ahead and do x times x, which is x squared, x times negative 2, which is negative 2x, plus parentheses 2x minus 1. Always get into the habit of putting parentheses on whatever term or binomial or trinomial it is that you're adding. Always just use parentheses. So then the denominator is going to stay the same, x minus 2 times x minus 1. Okay, so now I'm going to go ahead and distribute this positive inside. A positive times a positive is a positive. Positive times a negative is going to be a negative. So these are literally just going to stay the same. So you're going to get x squared minus 2x plus 2x minus 1 divided by x minus 2 times x minus 1. After that, we simplify, combining like terms. Well, what can I combine? This and this. Well, what's negative 2x plus 2x? They cancel out, so you are left with x squared minus 1 over x minus 2 times x minus 1. Now, you may believe that we're done with this problem, but we're not done because of something that we got when we simplified, and that is this x squared minus 1. Now, if you notice, the x squared has a power of 2. Not only that, it also has a minus 1. So what does that mean? That means that this numerator can be simplified even further by difference of squares. So at this point, you guys should be able to identify when you see a difference of squares, so that way you can simplify it even further, right? So that means that you're going to have a power of 2 minus a value, and it's going to be 2 terms. Now, the cool part about this is that when we do difference of squares, we're going to have to square root the first value, which is the x squared, and we're going to have to square root the 1 as well. Well, what is the square root of x squared? X. What is the square root of 1? 1. So what are you going to have? X plus 1 times x minus 1. So now, instead of putting x squared minus 1, I'm going to put x plus 1, x minus 1, divided by x minus 2, x minus 1. And then by doing that, I need to simplify even further by eliminating the common factors. X minus 1 cancel out because I have 1 in the numerator and the denominator. So my final answer for this problem is x plus 1 divided by x minus 2. Okay, now don't forget about the second part of this question. It says state any restrictions on the variables where x cannot equal to 1. And x cannot equal to 2. Remember, you got to get it from the original one, which would be this right here, the x minus 2, x minus 1. You equal those to 0. X minus 2 equal to 0. X minus 1 equal to 0. That means that x cannot equal to 2 and x cannot equal to 1. And so then right here, all of this would be your final answer. Okay, now moving on to example number 2. Okay, so it's the same thing. Here we have the difference. Why is it a difference? Because we have subtraction of the two rational expressions in simplest form. So once again, they want us to simplify. Okay, so we have to simplify all of this. Now, they also do want us to state any restrictions. So remember, the restrictions, where are they going to come from? They are going to come from the denominator. Okay, so just keep that in mind. Okay, now let's look at the fractions. I have an x plus 2. That's already simplified. I have another x plus 2, which is also simplified. This 2x minus 4, you can also think of it as being simplified, but we can simplify it even further because I do notice that this 2 and 4 are both divisible by one value. So we might try to do greatest common factor here. Now, I also do have this other denominator, x squared minus 2x. It may not be as obvious because they're variables and you usually tend to look at the numbers first and then the variables. But this denominator here also has a greatest common factor. Okay, well, what's the greatest common factor here? The greatest common factor here is going to be x, because this one has two x's and this one has an extra x. That means that there is something that I can take out from here to simplify it even further. So I'm going to go ahead and get x plus 2 over the greatest common factor of x squared minus 2x is going to be x. So if I have an x squared and I take one x out, I'm going to be left with x. Now, do remember that whatever you do take out has to go outside of the parentheses, okay? So x squared divided by x is just going to be x. Because you had 2, you took 1 away, so you're left with 1. I'm going to keep the minus, and now 2x divided by x is literally just going to be 2. So my new denominator, instead of x squared minus 2x, is going to be x times x minus 2. Okay, now we're going to continue to subtract with the numerator of x plus 2, which we're not going to do anything to yet. And then we're going to get 2x minus 4 and get the greatest common factor of 2, because 2 and 4 are both divisible by 2. Now remember, whatever you take out goes outside of the parentheses. 2x divided by 2 is just going to leave you with x minus 4 divided by 2 is 2. So here I'm going to have 2 times x minus 2. Okay, now we go ahead and look for the least common denominator, and then we go ahead and multiply by that least common denominator. So if I look at this here, I have an x minus 2 and an x minus 2, so that's the same. The only thing that's not the same is that here I have an x and over here I don't. So that means that the second fraction has to be multiplied by an x for sure. Okay, now another thing that I see here is this 2, but I don't see another 2 on the first fraction. So that means that the first fraction has to get multiplied by a 2. And then don't remember, what you do to the bottom, you also have to do to the top. Okay, so after that, we can go ahead and multiply them like this. Okay, and the denominators, if you notice, are going to be the same. 2, 2x, x minus 2. So after we multiply those numerators, we should be able to combine them into 1. So I'm going to get 2 times x, which is going to be 2x, and then 2 times 2, which is going to be 4, over 2x times x minus 2. And then I'm also going to put a subtraction because that's what we have here. Don't forget your parentheses. X times x is x squared. X times 2 is going to be 2x. And the denominator is literally the same thing, so I don't have to write it twice. Now, I did put a subtraction with parentheses. Reason being is that I need to distribute this in here. So if I distribute that, I'm going to get 2x plus 4. A negative times a positive is a negative x squared. A negative times a positive 2x is a negative 2x. All of this divided by 2x times x minus 2. Okay? So now we go ahead and simplify. Combine like terms. 2x, negative 2x. Cancel out to become 0. So you are left with x, negative x squared plus 4 divided by 2x times x minus 2. Now, you may think this is the simplest form. Now, the reason why this x squared is negative is because there was a subtraction in front of it, so I just made it negative, and the 4 has to be positive because it had a plus in front of it, so that's why I have that there. Now, once again, this is going to be difference of squares as well. Now, you may say, miss, but it has a plus, and you said that difference of squares was with subtraction, right? So I can go ahead and manipulate it into a way where it gives me a subtraction, right? How? By doing greatest common factor. So I'm going to do greatest common factor for this numerator right here. But what I'm going to factor out for this negative x squared plus 4 is a negative. Okay, so I'm going to factor out a negative. So that means that negative 1 goes on the outside, and then a negative divided by a negative is going to be a positive x squared, and then a positive divided by a negative is going to be a negative 4. And so if you notice that right there is now going to be a subtraction, meaning I can do difference of squares. Okay, so that means that I'm going to get the x squared and square root it to give me x, and then get the 4 and square root it to give me 2, so that I can get x plus 2, x minus 2. Now, does this negative go away? It does not, so I'm just going to put it on the outside. So I'm going to get negative x plus 2, parentheses x minus 2, divided by 2x times x minus 2. Simplify by eliminating common factors. It's this and this. So what are we left with? Negative parentheses x plus 2 divided by 2x. And that right there will be your your answer. But now remember, we need to also state the restrictions. So what was my denominator? Well, my denominator was this over here. So that means that we get 2x equal to 0, which is literally just going to be 0. So that means x cannot equal to 0. And then you get the x minus 2 equal to 0. So that means x cannot equal to 2. Okay, and now that right there is your final answer. Okay? Okay, so now we're going to go ahead and look at example number 3, where we are going to simplify the complex fraction. Now, if you look at this problem, it's very different from the other ones because you have a fraction within a fraction which are being added to each other. So how are we going to solve this? We're literally just going to do the same thing we've been doing before, except that now we have to do it for the denominator in the numerators and then the denominator in the denominator. Okay, so basically you still cannot add nor subtract these fractions until they have the same denominator. Okay, so now let's go ahead and do this problem. Now here, how we're going to solve this is that the first step that we are going to do is that we are going to multiply the numerator and denominator by the least common denominator of all the rational expressions. So that means that we have to look at every single one of these fractions and find the least common denominator of all of them, okay? And then from there, we should be able to just, simplify and then get our final answer, right? So that's what we're going to do. So that's the part about this one. We want to find the least common denominator of all of the rational expressions. So that means that if you look at the top, in order for me to add these fractions, I would actually have to multiply times y over here. And what I did to the bottom, I do to the top. Now we have to, I put y, but it should be x here. And so if you notice here, the least common denominator is going to be x and y. So that means that for the numerator, I multiply it times x and y. And for the denominator, I'm also going to multiply it times x times y. Okay? So that right there is going to be my least common denominator of all of them. Okay? That's what it says here. Of all the rational expressions. Okay? So if I rewrite this, I'm going to get 1 over x plus xy times xy, the least common denominator, over 1 over y plus 1 times xy. So now we're going to go ahead and distribute this using the distributive property. Now, do keep in mind that when you're multiplying fractions with whole numbers, you literally just have to multiply it to the top. So I'm going to multiply this and distribute this just to the numerators right here. Okay, so by doing that, I'm going to get xy times 1, it's going to be xy over x, plus xy times x is going to be x squared y over xy times 1 is going to be xy over y, plus 1 times xy is just xy. Okay, so now check this out. We're going to look for the common factors or whatever they have in common and just cancel that out. So if you see this xyx right here, okay, what do they have in common? Well, they have the x in common, so we cancel that out. And if you look at the second one over here, what do they have in common? The y's. So those cancel out. Y's are also here in common, so that cancels out. So what are you left with? You're left with y plus x squared over x plus xy. And that right there is your answer. Okay, and what would be the restrictions? Well, x cannot equal to 0 and y cannot equal to 0, because if you put a 0 for x or 0 for y, then they're going to give you a denominator of 0. And that is all for today's lesson. Let me know if you guys have any questions.